Hello everyone, welcome to BYJU'S exam prep. Hope you guys are fine. So guys, be quick and join the session fast so that quickly we should start with the numerical session of alkalinity. So guys, be quick, be fast so that we'll be starting the session and we'll complete the number of questions as early as possible. So be quick in joining the session fast guys. Okay. Till then, let me tell you a few things before we proceed. Okay. So, if you are new to this channel, do subscribe as I always say so that you can know the further upcoming sessions and all. And if you are new to this channel and if you don't know about me, you can go through my profile. Next, coming further, guys, if you're preparing for GATE 2024 and you think that GATE cannot be clear in a single attempt, so there is a free workshop on 7th of May, that is tomorrow at 12:30 p.m. by Rasul Chutwani. He is an all India rank holder 12. So what are the things which he did for getting a good rank on the very first attempt? So you guys can ask your query as well. This workshop will be on the app. Good evening, Arun. I'm good. Arun, I was to say, I guess you are in the Telegram group now. I was not able to tag you. I was to say, you asked me na engineering mathematics. So I downloaded the previous year's ISRO paper. In that, engineering mathematics was asked. But I told you na that time it was by CPEO. This time it is by CPEO. Civil Program Engineering Office. So that is the reason. But if you see the last year papers, engineering mathematics was included. So you were asking me, na? I was thinking to tell you. Okay. So guys, let's move forward. So if you're new to this and you don't know when the classes will be coming, so you can join my Telegram group for further upcoming classes. Okay, so now let's not waste time. We'll be starting, and if you want to download or basically if you want number of more questions, ebook is link is in the description for GATE. You can download it. Okay, now before starting numericals, just 5 minutes I'll tell you some important things, and then quickly we'll move to the numericals part. We'll complete as early as possible. Okay, a few things which I'll be telling you. Some people like alkalinity we express in terms of calcium carbonate. So alkalinity in mg per liter as calcium carbonate. This is equal to, generally we know there are many minor ions also which causes alkalinity, but majorly the ions which are responsible for alkalinity is carbonate, bicarbonate and hydroxyl ions. So generally some books when you study you find this formula. Well, I don't find this very basically something which you have to remember. If you are clear with your concepts, no need for this formula. Okay. इसरो का इसलिए याद था मुझे. हाँ, अरुण आपने जो पेपर दिया था ना वो इसरो ने ही रिलीज किया था. बट जैसे इसरो में अलग अलग डिपार्टमेंट्स होते हैं ना, तो इस बार ये डिपार्टमेंटल पेपर इसरो के अंदर, तो ये पहले ऑर्गेनाइज नहीं हुआ है. पर हम मान के चल रहे कि इंजीनियरिंग मैथमेटिक्स आएगा, क्योंकि हर बार जैसे मैंने बोला जो पेपर आप दिए हो ना उसकी भी वैकेंसी आने वाली है. ठीक है, ये एक्सक्लूसिवली सीपीईओ ने रिलीज किया है. ओके जैसे कि अगर आप बात करो तो यूपीएससी से आपको अलग अलग आप बीआरओ में जा सकते हो, आप वाटर कमीशन में जा सकते हो, बहुत सारे होते हैं. बट अगर बीआरओ सेपरेट अपनी पोस्ट निकालता है तो वो तो अलग हो गया ना. तो वैसे ही इसरो का जो नॉर्मल पेपर जो आप हर साल देते हो उसकी भी वैकेंसी आने की प्रोबेबिलिटी है. बट अभी जो रिलीज किया गया है वो सीपीईओ ने रिलीज किया है. ठीक है, हालांकि उनको स्पेसिफाई करना था बट अब उन्होंने सिविल सिलेबस बोल दिया तो हम मान के चल रहे इंजीनियरिंग मैथमेटिक्स इंक्लूडेड. ठीक है, चलो अब वापस आ जाते हैं इसमें. अब चलो पूरा का पूरा ध्यान एल्केनिटी में. लेट्स कंप्लीट इट इन 30-40 मिनट्स मैक्स टू मैक्स. बट मैं कुछ कुछ कंसेप्ट्स पहले बता दूं. तो एल्केनिटी, द वन विच यू हैव टू एक्सप्रेस एल्केनिटी, वी एक्सप्रेस इट इन टर्म्स ऑफ कैल्शियम कार्बोनेट. सो कंसंट्रेशन ऑफ कार्बोनेट divided by equivalent weight of carbonate into equivalent weight of calcium carbonate. Similarly, concentration of bicarbonate divided by equivalent weight of bicarbonate into equivalent weight of calcium carbonate. Last is concentration of hydroxyl ion divided by, and these concentrations are in mg per liter. Okay, these concentrations are in mg per liter. Here also it is in mg per liter divided by equivalent weight of OH minus into equivalent weight of calcium. See, it is very important to see in the question whether the concentration is given in milligram per liter or is it given in milliequivalents per liter. Now, if you don't know what is the meaning of milliequivalents per liter, so first let me tell you what is equivalent weight. So, equivalent weight of anything is the molecular weight divided by valency. First of all, okay. Next, coming further, concentration is given to you in mg per liter. So, you will use this. If it is given to you in milliequivalents per liter, that means let us suppose if concentration of carbonate is given by let us suppose 4 milliequivalents per liter. It means it is trying to say concentration of carbonate divided by equivalent weight of carbonate. So if they give you milliequivalents per liter, that means they are giving you this whole value. Okay, so if they give you milliequivalents per liter of carbonates, that means they are giving you concentration of that carbonate divided by equivalent weight of carbonate. So this is the meaning of it. Now there's one more thing which I have to tell you. That's it. Then we'll move to the numericals. Some people, some examinations also you have theoretical questions in that, and some books also when you refer standard textbook you have this term as negative alkalinity. Now, technically speaking, there is nothing called as negative alkalinity, but still sometimes they ask you, that's why I'm telling you, those compounds which does not impart alkalinity. Or alkalinity means ability of water to neutralize acid. From where does the water gets this ability? Because of the ions, to be precise, anions which is present in them. Got it? Now what happens, the alkalinity is due to carbonate. So you will add, if they ask you, carbonate will be there, bicarbonate will be there, hydroxyl will be there. But H plus ion does not impart alkalinity. So you say since it does not impart alkalinity, you will subtract. So that's why some of the, you can say, examinations, there are 4 options in which they have subtracted this, added this. So total alkalinity, if they ask you in this manner, so this is the total alkalinity. However, let me tell you, in maximum cases, the value of H plus is so small that we neglect it. Example, if the total alkalinity was coming 150 mg per liter, and if you talk about H plus, generally when the pH is 10 around, so the total alkalinity, if you take H plus, will come 149.9999, which is approximately 150 only. So generally we don't consider, but if in the question it is deliberately telling us to consider the impact of negative alkalinity, then we have to consider. Okay, so that's it. Fine. So now we'll move to the first question. I guess it is visible, or is it stuck because of my head? Okay, if it is, what is not? I think it's there. You don't need everything. You have to, many other things are given in the question which is not required. Chloride, carbonate, calcium, magnesium, bicarbonate. Come on, guys. Chloride, carbonate, calcium, magnesium, bicarbonate. You have to tell the alkalinity present. So here what you will take, chloride, no, only carbonate. Carbonate you will take and bicarbonate you will take. Okay. So carbonate and bicarbonate, carbonate if you are not able to see because of my head, so it is 30. Check it out the units, it is given in milliequivalents per liter. So you have to do nothing. Carbonates plus bicarbonates are responsible. So carbonate is 12 and bicarbonate is 30. Already concentration divided by equivalent weight is given. So just multiply by 50. How much it is coming? How much it is coming? If you are clear with your concept, you don't need to do that big formulas or big statements and apply it. This is more than sufficient. Correct, Arun? 2100. Okay. Now, moving towards the next question, this question. I told you a ready-made formula for such type of question, guys. Very ready-made formula. Means just one thing and you'll get the answer. Those students who have joined today's class and they haven't attended yesterday's, Thursday's class. So guys, there's a playlist. You can see alkalinity, chemical water quality parameter alkalinity. There, I almost an hour I took to explain everything about to you regarding alkalinity. So kindly go and see that also. Okay. So now see a 200 ml water sample. So the sample of water which is given to you is 200 ml. So Y is given to you as 200 ml. Okay. And then what is there here? You have a burette in which 0.02 normal H2SO4 titrant is there. That is that chemical. And how much of the chemical is used? How much of that chemical or titrant is used? V. How much is used? 30 ml. Okay, entire, that means up to 0.4.5, carbonate, bicarbonate, caustic, entire alkalinity is being neutralized. So it is asking you the alkalinity. I told you either you go by conventional, so why to waste time? I already told you how much will be the alkalinity. V milligram per YML. So total alkalinity in mg per liter as calcium carbonate. V milligram per YML. So how much is titrant used? 30. What is the water sample? 200 ml. ml if you want to convert it into liters, divide by 1000. How much it will come? 21,550. Got it? So read in a single line you will get the answer. Don't have to go through the conventional process every time. Okay? So this is the second question. Now coming towards the third question. Guys, you want to solve, remember I always told you that we take H2SO4, but now here what is given to you? Instead of H2SO4, normality is same, but now instead of H2SO4, NaOH is given. So I'll tell you three different methods and you guys don't remember it and you start to mug up the formulas, you know that? So I'll tell you that formula which you see it in books also, but let's move on. This is 60 ml of water sample and the titrant which was used, that is VML, that is given to you is 35 ml. Now, first I'll tell you V milligram per YML. This you can do only when the normality is 0.02. If they'll change the normality, then it will change. Otherwise, it will remain same. Okay. So V milligram per YML. So how much? 35 milligram and 60 divided by 1000. How much it will come? 35 into 1000 divided by 60. So this will come out to be 583.33 mg per liter as calcium carbonate. Okay. Or the basic method which you know, 0.02 normal NaOH. Normality means number of gram equivalents present in 1 liter of solution. 1 liter means 1000 ml. So in 1000 ml, 0.02 gram equivalents of NaOH is present. So how much titrant is used? VML. So in VML, how much will be gram equivalents of NaOH? 0.02 into V divided by 1000 gram equivalents of NaOH. And you know 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing. So these many gram equivalents of NaOH will be equal to these many gram equivalents of calcium carbonate. Now if you want to remove this equivalent, you multiply by the equivalent weight of calcium carbonate as we studied yesterday, which is 50. Now if you want to convert, see ml and ml is already gone. ml and ml is already gone. Now if you want to convert gram into milligram, 10 raised to power 3 milligram. So from here you will get V milligram. This much amount of titrant was used in how much amount of water sample? By ml. That's it. So instead of VML, you could take it here 35 ml. You will get 35 by 60, which I have done it. Okay. Now, generally students have one, you can say formula which they use it, which I personally say that you don't need to use that formula. Now, it depends entirely on you that if you want to use it, surely you can use it. But I'll tell you that formula. Wait, I'll add a slide. Okay, fine. Now I'll tell you. Okay, the formula for it is the same here only I'll draw. Anybody knows it? Oh, Varun, you got the correct answer. Okay, fine. Total acidity in mg per liter as calcium carbonate. Okay, they write it like this. When you see the books, they have written like this. Exactly what I have written. V, okay, V into normality into equivalent weight of calcium carbonate into 10 raised to power 3. See, here if you see volume into normality was 0.02, equivalent weight was 50 and 10 raised to power 3 added divided by volume of water sample tested. So they have found this formula. You don't have to mug it up. They have found it from the basic concept. But if you are okay with learning it, that's your call. Got it, Arun and everybody else? Okay. Now here also you have got this much only. Volume used 35. Normality 0.02. Equivalent weight 50. 10 raised to power 3. Volume of water sample used 60. Tested basically. Okay. Same thing is there. Okay. Now, fourth question. Now you will be answering me. This is an MCQ question. Consider the following statement. Choose the incorrect one. Now this one I am not going to tell. You will be telling me. Very simple question. Come on guys. Very simple question, MCQ question. The quantity of ions that react to neutralize the H plus ion is called alkalinity, of course. Ability of water to neutralize acid, basically concentration of ions which are capable of neutralizing H plus ions or your hydronium ion. So first statement is correct. Total alkalinity is the summation of caustic, bicarbonate and carbonate. Yes. Alkalinity is generally expressed in mg per liter as calcium carbonate. Correct. Alkalinity caused by HNO3, nitrate ion, is called carbonate alkalinity. No, it is due to CO3 2 minus. B. Correct. Okay. Fine. Now coming further to this question. This is a very important question. One question and all your, you can say the single question will cover all your doubts. Okay. Now see this question very carefully. A 200 ml sample of water. So the sample of water which we denoted by Y. This is 200 ml. You can take X, Y, whatever you want. I took the denotation Y. I was comfortable. You can take any denotation. There is no hard and fast rule. Okay. Now 200 ml sample of water has an initial pH of 10. 30 ml of 0.02 normal H2SO4 is required to titrate the sample up to 4.5. I told you at yesterday, that means on Thursday when I took the class, I shared with you a table. At pH of 8.3, what happens? Caustic and half of carbonate alkalinity is neutralized. From 8.3 to 4.5, half of carbonate and bicarbonate alkalinity is neutralized. And at pH of 4.5, carbonate, bicarbonate and caustic alkalinity is neutralized. So it is talking about pH 4.5. So at pH 4.5, what was happening? Entire alkalinity is neutralized. So this will be PML or MML? PML or MML? MML, because entire volume M 30. Now it is asking what is the total alkalinity of water in mg per liter as calcium carbonate. This is very simple. Entire from 10 to 8.3 and 8.3 to 4.5. So right now in the first 2.5 statement, they haven't mentioned nothing about 8.3. So that means from 10 to 4.5 it is directly talking. So means it has given the entire acid which is used for complete neutralization. So total alkalinity in mg per liter as calcium carbonate. Here I have taken M. Bye. Technically it is volume. So here the volume of acid used was 30 ml as calcium carbonate. Right. So M was how much? 30 milligram. Y is 200 ml. ml converted into liters. So this will be 150 mg per liter as calcium carbonate. This is the total alkalinity. Good evening, English Academy. Okay, this is the total alkalinity, means carbonate plus bicarbonate plus caustic. Now lead the next statement. Also find the concentration of each alkaline species if 11 ml of 0.02 normal is required, 0.02 normal H2SO4 is required to bring the pH of system at 8.3. That means at 8.3 what is happening? Caustic plus half of carbonate alkalinity is neutralized. Okay, so again V milligram per Y ml. So how much amount of acid is used? 11. And how much is the water sample? 200 ml. So convert it into liters. Ones are, fives are, 55 mg per liter as calcium carbonate. Now, in the question, it is asking me to calculate concentration of each species. That means it is asking to calculate caustic, it is asking to calculate bicarbonate and carbonate. All the three it is asking. Right now, this is one equation which I have got, and this is one equation I have got. See, three unknowns and two equations. Will I be able to solve it, guys? This is 150. Three unknowns. Can I be able to solve it? Yes or no? No. Oh, Varun already got the answer. Very good. What shall I do then? Added slides. Fine. Okay. So what shall I do is, in the question they have given me what one thing was given to me. Anybody can guess? pH is 10. You know very well that pH plus pOH is equal to 10. pH plus pOH is equal to 14. pH is given to you as 10. That means pOH will come out to be how much? 4. Okay. pOH, you know, it is minus log base 10 OH minus ion concentration. So OH minus ion concentration will become how much? 10 raised to minus 4 moles per liter. But you don't want in moles per liter. You want in mg per liter. Now you know, if you want to convert moles into gram per liter, just multiply with the molecular weight, because number of moles means given weight divided by molecular weight. So you just multiply with the molecular weight. Molecular weight comes out to be how much? Oxygen 16, hydrogen 1. So 17. This will be 17, 10 into 10 raised to power minus 4 grams per liter. But you want to convert it into gram equivalents. So if you want to convert it into gram equivalents, you will divide by the equivalent weight of OH minus. Equivalent weight of OH minus. Molecular weight divided by valency. OH minus has a molecular weight of 17 and valency minus 1. So this is 1 only. So equivalent weight is also 17. So when you will calculate the gram equivalents, these are the gram equivalents of OH minus. So this will come out to be how much? 10 raised to power minus 4. 17 and 17 will get cut. Now you know 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing. So these many gram equivalents of OH minus will be equal to these many gram equivalents of calcium carbonate. If anybody is having doubt, kindly ask me here only. Moles, I know moles is equal to given weight divided by molecular weight. So I want to get the given weight. That's why I multiplied with the molecular weight. Now after that I have got the weight. I want basically I got the concentration. So I wanted what? I wanted the equivalent weight. Basically gram equivalent. So I divided by the equivalent weight. Okay. Now these are the 10 raised to power minus 4 is the gram equivalents of calcium carbonate also. But I want to remove this equivalent. I don't want this equivalent. I want to remove this equivalent. So what I will do is I'll multiply by 50, which is the equivalent weight of calcium carbonate, and I'll, for converting gram into milligram, I'll multiply by 10 raised to power 3. So how much I'll get, guys? Anybody got the answer? How much you will get? So everything will get cancelled out. Nobody. Oh, Arun got it. Very good. 5 mg per liter. That's it. Now everything you will able to calculate. I got OH minus is 5 mg per liter. So you will substitute 5 here. Half of CO3 2 minus is equal to 55. 55 minus 5 is 50. 50 into 2 is 100. So carbonate alkalinity will come out to be how much? 100 mg per liter as calcium carbonate. Okay. 100 you got, 5 you got. Total you know it will come out to be 150. I'll write it here. You know CO3 2 minus plus HCO3 minus plus OH minus is 150. Now you already got carbonate as 100. This as 5. How much will be bicarbonate ion? How much will be bicarbonate ion, guys? 45. 150 minus 105. Got it? So this is a good question. This covers each and every aspect. But this question you will be able to solve if you know the concept. Because you should know at pH of 4.5, entire alkalinity is neutralized. At pH 8.3, caustic and half of carbonate alkalinity is neutralized. So if you know, then only you will be able to solve it. Okay? Fine. Now this question. I'll advise you to go through the options. The alkalinity means total alkalinity. Total alkalinity in water is given to you as 350 mg per liter. And P alkalinity, that means 200 mg per liter. I will advise you to go through the options. First, you add any of the four options, you will get 350 mg per liter. Firstly. Secondly, if you see it here, then you can see common sense that P, I told you various types of cases in yesterday's class. So P is greater than M by 2. That means acid used in first stage is greater than half the acid used in both the stages. So guys, check it out. Check it out. Tell me. Very simple. Use the options and tell me which one will be the correct option. See, let me take the first. If I take carbonate as 300 mg per liter and OH minus as 50. So half of 300 will become 150. 150 plus 50 is 200. Correct. 300 plus 50, bicarbonate is 0 will become 350. Correct. I have just substituted the values. If I take these values and if I put it in the equation, my equation is getting satisfied. So option A is the correct. So it's not everywhere you have to go through the lengthy process. Here there was nothing like NAT question sort of. So I have proceeded through the options. Got it? Understood, Arun? Everybody else? Understood? Okay. Now, go through the options. This is total alkalinity. We say M, they have said T. They can use anything what they want. This is P. Okay. Now, moving to this question. Remember, this question, check it out. They have given the concentration in mg per liter, not in milliequivalents per liter. Here also you have only carbonate and bicarbonate. So if you don't know, I'll just tell you the equivalent weight of carbonate and bicarbonate, and you don't means you should have practiced a number of questions that this will be in your fingertips. Carbonate molecular weight is 60 and valency is 2, so 30. And if you talk about equivalent weight of bicarbonate, molecular weight of HCO3 minus is 61 and valency is 1. So this will be 60. Okay. Now just I told you the formula, but you don't know, you don't go through that. Simple is calcium plus bicarbonate. Calcium is given how much? 240. This is given in mg per liter. So first convert it in terms of milliequivalents. Divide by the equivalent weight of calcium carbonate, which is 30. You could do it 50 here, or you can take it common and do it at the last. Concentration of bicarbonate is 1525 mg per liter. Divide by equivalent weight, which is 61 into 50. How much it is coming? 25 divided by 61 to 50. 1650. Got it? Fine. So I guess, and last question is homework for you. Same question, same pattern of question, but in this question, milliequivalence is given. If you want, you can solve it now. I have solved two pattern of questions, one in mg per liter and one in milliequivalence per liter. So now you can solve instead of bicarbonate here, hydroxyl is given, but anyways, you don't have to use equivalent weight concept here. Basically, because you don't have to divide by equivalent weight because already it is given in milliequivalence per liter. So guys, this is homework, solve it. And if you're solving it, reply now, or you want, then you can reply in the comment section as well. Okay. So with this, we complete our numericals on alkalinity, and we'll be having more sessions. In the upcoming on 10th of May, I'll be dealing with if you are doing job and you're thinking of cracking gate and ESE, is it possible or not? We'll be discussing that. So there'll be many things which we'll be discussing. Anybody got the answer, or you will be doing it later? Very simple, just a single line answer it is there, but I don't want to do it. You will be doing it. Carbonate and hydroxyl ion is there. Okay. So that's all for today, guys. That's all for today. And scholarship test, you can give this test up to 90% scholarship is there. Link is in the description. You guys can register. And if you haven't downloaded the BYJU'S exam prep, do so. It's available in the Play Store for the free app live classes. And that's it. So good night, everybody. 2050. Very good, Arun. Very good. That's the correct answer. So that's all for today, guys. Do subscribe the channel if you haven't, and take care of yourself. Bye bye and steady heart.